Okay, this is the Charles's Law warm-up. Okay, a sample of gas has a volume of 150 milliliters at a temperature of 25 degrees Celsius. If the temperature is dropped to 0 degrees Celsius, what's the new volume? Okay, before we get started, let's go ahead and label what we've got. So I'm going to do that in green. So we have a volume. So this is our first volume. And we have our first temperature here. And then if the temperatures drop, so that's our T2, and we're looking for V2. Okay, now don't forget, with the gas laws, temperature has to be in Kelvin, not degrees Celsius. So when I put these into the equation, I'm going to be adding 273 to both of these temperatures in order to get my Kelvin temperature. So our equation, of course, is V1 over T1 equals V2 over T2. So now we're just going to plug in the numbers. V1 is 150. Now, what I do want to see for you guys, especially when we do have a quiz and you're showing me the work, you can either do one of two things. You can define the variables. So you can put V1 equals, T1 equals, V2 equals, and T2 equals. Or you can just put the units in the equation. Okay, and then do what I did up here, like with labeling what each is in the equation itself. Either way works. I don't care how you do it, but just so that I know that you know which one's which. So we have 150 mils and 298K equals V2 over 273K. Okay, now we're going to cross multiply. Now, if you remember, we're going to multiply by these two and then divide by that. So it's 150 times 273 divided by 298. So that gives me a V2 of 137 milliliters. Okay, let's try another one. Okay, so for this one, once again, we're going to go ahead and put a little variable thingies on top of these. So a sample of gas has a volume of 725 milliliters. So I'm going to put my V1. Now, this is where it kind of gets a little tricky. It says, if the temperature is dropped to 10 degrees Celsius, that means it's a second temperature. It's not the first temperature. Okay, the volume falls to 750 mils. So that's our second volume. And just to be sure, it even says, what is the initial temperature, which is our T, oops, that should be T2, which is our T1, okay? So when we put this into the equation, don't forget, we're looking for T1. So we have V1 is 725 milliliters divided by T1 equals 700 milliliters divided by 283K. Don't forget, we have to put this into Kelvin. It's not Celsius. Okay, so we're going to multiply. So it's going to be 725 times 283 divided by 700. So our T1 equals 293K. Now, the original temperature in the problem is in Celsius. That means I have to convert this temperature to Celsius. So I'm going to subtract 273, and I get 20 degrees Celsius. Okay, so on a quiz, if you forget to do this step, it's going to take off a point, because if I have Celsius in the beginning, I got to have Celsius at the end. Okay, let's do another one. Okay, a sample of gas has an initial temperature of 0 degrees Celsius. So there's my T1. If the temperature is raised to 25 degrees Celsius, so there's my T2, the new volume is 467 milliliters. So there's my V2. What was the initial volume? So what I'm looking for is V1 here. Okay, so let's go ahead and put this in my equation. So V1 over T1, which is 273K, equals V2, which is 467 milliliters, divided by 298K. So V1 equals 467 times 273 divided by 298. V1 is 428 milliliters. Hopefully this is getting easy for you guys. Okay, let's try one more. Okay, a sample of gas has a volume of 1.60 liters, so there's our first volume, at a temperature of 28 degrees Celsius, T1. What is the new temperature, or T2, if the volume increases to 1,750 milliliters, V2. Okay, volume units have to be the same. So I either have to convert to liters or to milliliters, one of the two. Before we go any further, I'm going to give you guys a liter bridge, kind of like the mole bridge, only it's how to convert between the two. So we're going to put liters here and milliliters here. So I'm going this way, going from liters to milliliters. I'm going to multiply by 1,000. If I'm going from milliliters to liters, I'm going to divide by 1,000. Okay, I would have this written down somewhere. That way you have access to it. Okay, so we're going from 1750. So we're going from milliliters to liters. 1750 divided by 1,000 is 1.75 liters. Okay, so there's my V2. So actually, let me move this up a little bit. Well, just to here. Okay, so my V1 is 1.60 liters. My T1 is 28 degrees Celsius, or 301 K. And then my V2 is 1.75 liters. Oops. And I'm looking for T2. So T2 equals 301 times 1.75 divided by 1.6. Oh, okay, I'm going to move it up a little bit. Okay, so T2 comes out to equal 329 K. And once again, I'm giving my original temperature in Celsius, so I got to convert to Celsius. So that becomes 56 degrees Celsius. Hopefully that helped, guys. Our next thing will be Gay-Lussac's law and some more gas laws. But for now, have fun. Bye.